Investigators, welcome to Learn Extra Live. We're doing what? Physical science.
Yeah.
I almost said life science because that's later. That is later. Don't forget that. But right now, it's physical science with John. You guys know John, right? Welcome, John. How are you?
Thanks, Katlego. It's great to be with you. And guys, this morning we're getting into organic chemistry. So it doesn't. That's why you mixed
that's
up.
why I mixed it
because
up.
it's kind of a little bit of life science, a little bit of physical
and
science,
I know this
organic
is your
chemistry.
favorite, so you are
It's
really going to enjoy
absolutely my
this.
favorite part of chemistry. I love organic chemistry, and so I'm really looking forward to taking you through some questions. We're going to be starting off by looking at the November 2011 past paper, just the organic chemistry questions. But guys, if there are any questions you've got, you can phone in, you can post, and I'll be happy to take them.
Awesome,
Okay.
John. Thank you. I know that you
I'm
guys
just going to
will-
go to the board.
Okay, awesome. I know that you guys will enjoy the show today because it is going to be an exciting one. If you have any questions, you can ask them throughout the show. Anything on organic chemistry, we are here. And also, even more awesome, we have our awesome competition. You guys know all about the competition. There are many ways to answer the question as well. There's our Facebook events wall. Remember the events wall. And then there's pep text. You guys know all about pep text by now. It's Friday. And there's also our email, win@learnextra. You can email us and send us everything, even your details. Be eager and send your details right from the beginning. And then there's also our SMS. Everything can be found on Facebook, so you guys will be in tune and ready for that. John's going to tell us all about the question, so you guys know that you guys will be set for today. Also, again, thank you to Liberty. Liberty is awesome. They've been sponsoring our shows. So, yeah, lovely to Liberty. It may be our last show of winter school for grade 12s, but next week will be grade 11s. And you guys must tune in for that because it has a lot to do with your syllabus as well.
That's right, Katlego. Absolutely, particularly for physical sciences, guys. There are sections in your final exam paper that maybe you won't be able to revise in class, but they're going to come up in the exams.
Awesome.
So make sure that you join us for grade 11 on Monday, Tuesday, Wednesday, and Thursday. Physical science, maths, life science, maths literacy, be there. Don't think that today's the last time. We're on next week as well.
Yeah. Okay, awesome. Can you tell us about that question, John?
Okay, sure. Guys, I want to take you to the Facebook page, and there are a couple of things here just to remind you. On the Facebook page, that's the main page. What you want to do is go to the events page. I've already done that. And on the events page, we've posted the question. And let's just quickly read that question for you. It says the following. It says, the reaction of iodine and 2-methyl-butene is A, substitution reaction, B, elimination reaction, and C, addition reaction. Now, the code for this question is 1669. Now, if you're on the Facebook page, you need to answer. We see we've got Lorraine's already answered, but you need to answer in this part here. Under the question, you need to comment. Write in as a comment on the page. Otherwise, use the other ways of doing it. I've had a lot of people phoning saying, guys, I haven't got a WAP-enabled phone. How do I get it? Use the SMS number and SMS us. We'll make sure that you've got that. Look out for the SMS number and send us your requests as well as far as that's concerned. Now, there's another thing that's happening on Facebook I just want to go back to, and I want to encourage you to let your friends know we're almost at 13,000.
13,000, it's
Can you
going to be
believe it?
amazing.
That's
I'm excited.
amazing. That's great. Now, we want to get the grade 11s. And here's the challenge to you. Grade 12 learners, let your grade 11 colleagues and friends know. Get them to like the page. Go to the main page and get them to like us over here. Just get onto that page and we want to push the likes. Maybe even this show. We're only about 30 away, just under 30. Let's get those likes up. We want to get to 13,000.
Awesome. I'm excited for 13,000.
Okay, guys, let's get straight into it. And we're going to start with our organic chemistry question. And the first thing we're going to do, we don't do this very often, is in your exam paper, there is question 1, which is all about short answers. You're asked to provide a one-word or a term that answers the question. So let's go and have a look at it. I've just taken out the ones that are relevant for organic chemistry, but let's have a look at it. So this is adapted from the 2011 paper. It says gives one word or term for the following descriptions. And the first one says the homologous series to which we want to know what that word is, to which the compound CH3Cl belongs. Now, if you think about it, what is homologous series? So it's a word that we battle to pronounce, and what it means is it's the family, it's the organic family that have the same sort of formula, they have the same sort of characteristics. Well, let's have a look at it. We've got CH3 and a Cl. Now, CH3 says it's got carbon and hydrogen, and it's got a Cl. Now, Cl is one of the halogens. So the homologous series that this belongs to is one of the haloalkanes. Let's just correct my writing there. Halo, and we're going to write alkanes. The reason I said it was a haloalkane is because it has the carbon has 4 bonds. So if we draw the structural formula, then you'll see that there are 3 hydrogens and 1 chlorine. So there's the structural formula of the molecule, and you should be able to see carbon has got 4 bonds. Every carbon, remember, has 4 bonds, and there's a halogen, and otherwise there are hydrogens. So it's a haloalkane. Very important, halo being for the halogen, alkane telling us the number of bonds, that it's not a haloalkene or haloalkyne, where it would have a double bond or a triple bond in it. Now, the alternative name for haloalkane is we could say it's an alkyl halide. This is an old-fashioned way of saying it, but it would be considered correct, but we just put it there in case some of you have been taught that alkyl being that it is a group of carbon with hydrogens, and halide saying it's got the chlorine attached to it. Right, let's go to the next question. It says the general term that describes compounds that consists of hydrogen and carbon only. Now, I can hear you. You're jumping out of your seats. You know exactly what this is. It's about organic chemistry, and it's about those that have hydrogen and carbon only. Those are the hydrocarbons. Now, guys, these questions in question number 1, they're straightforward. They're one word or one term that you want to give, and they're there for you to get confidence and to get marks right up front. Now, there's some debate amongst teachers about whether you should be answering those first or not. I believe that it's really important in your reading time to read those through. You can even scribble down the answers. For the multiple choice, question number 2, I think you need to take a little bit more time. These ones you can do quickly. You've usually got to answer them on an answer sheet, not in your book. You're just putting down the answers in the special answer sheet. So get the marks on the board as quickly as you can, but I'd also recommend that you leave the multiple choice questions until a little later, because sometimes those multiple choice questions can be a little tricky. But we're going to go to the organic chemistry ones now, and let's have a look at them. So question number 2, 2.1, and I just want to get it right up there. It says the following: which one, and it's in capital letter, of the following general formula represents alkynes? Now, see what I've done? I've underlined the words, the key words. We want a general formula and we want alkynes. So let's just stop there. The homologous series, the family that are the alkynes, what do they have in common? Well, they have a special functional group, and you should know this. Alkynes ending in YNE means that there is a triple bond present. One triple bond is present. The general formula for this is CnH2n minus 2. because for every triple bond we take, or every bond more than a single bond, we take off 2 hydrogens. So you should be able to work it out. Alkynes, general formula, we know alkynes, CnH2n minus 2. Remember, the alkanes are CnH2n plus 2. Those only have single bonds. And the alkenes are CnH2n because they have a double bond, one double bond. And so every time we go up, from starting at the alkanes was CnH2n plus 2. Now we move 2 off, that's 2n. And for the alkenes, it's another minus 2. So we're taking off 2 hydrogens every time we make an extra bond. If that makes sense? See, we worked it out. We didn't even look at the options. Once you've worked it out, now you can go and look at the options and say, which one is it? Well, it clearly must be that one. It's answer B is the one that we're wanting to select. Let's go to our next multiple choice question. Which one of the following homologous series, okay, does not contain a carbonyl group? Carbonyl group, and they tell you what it is. It tells you that it's a carbon with a double bonded oxygen and something like that. So, guys, now we need to think about it. Which ones do have a carbonyl group? Which one have oxygen in them? Let's now remember what things have carbonyls. We have the aldehydes. The carbonyl group on an aldehyde is at the end of the molecule. Then we have the ketones. The carbonyl group is in the middle of the molecule, not at the ends. That's the difference between aldehydes and ketones. Then we get to esters. They also have a carbonyl group. What about carboxylic acids? They also have a carbonyl group. Okay? Those are the ones that you need to know that have carbonyl groups on them. So which one isn't there? Let's have a look, and you see. Aldehyde, yes, we've just been over it. Aldehyde, it's got a carbonyl group, so it can't be. Carboxylic acids, yes. Esters, yes. The one that does not have, and it's underlined, does not have, is the alcohol. So the answer to this multiple choice question is number B. So please remember that. Try and work it out for yourself. Do the quick revision, and you can do that revision during your reading time even and make your selection so that you've got it very clear in your mind. It's also a good idea to just check your multiple choice when you're doing the main organic question. You start to think about organic chemistry with the organic chemistry from the multiple choice. There's nothing wrong in doing that. So you just answer the organic chemistry multiple choice questions and then go on and do the organic chemistry. Come back. But the one thing about multiple choice, never leave a multiple choice question out. Okay, let's get to the last one that we've got here, which is 2.3. It gives you a diagram of structural formula for organic compounds are shown below. Number one over here, number 2 over here, number 3 over here, and number 4 over here. And it says, which of the above have the same IUPAC name? Now, guys, IUPAC is the systematic way of naming organic compounds. The thing that we need to recognize, if it has the same IUPAC name, it must have the same number of carbons, and they must be arranged in the same order. So let's just check that out. First thing, to check the number of carbons. So over here, 1, 2, 1, call this number 1, call this number 2, call this number 3, call that number 4, and there are 5 carbons there. And this one, 1, 2, 3, 4, 5. And over here, 1, 2, 3, 4, 5. And over here, 1, 2, 3, 4, 5. So they all have 5 carbons. So we recognize they all have the same, and we had to count the hydrogens and the oxygen. We recognize they have the same molecular formula. Remember, a molecular formula is written as C5, and then if we did the hydrogens quickly, 3 and 3 is 6, and another 3 is 9, and another 3 is 12. So it's C5H12 and an O, and that's the molecular formula. It's different to the structural formula, the one that you can see in the diagram, but they've all got the same molecular formula, so we can't eliminate it on that. What we've got to now do is eliminate it using the IUPAC rules about numbering the carbon chain. Now remember, you number the carbon chain from the functional group, and I'm going to do that very quickly. Just start over here. I want to get the functional group, which is the hydroxide, the alcohol functional group, as low as possible. So let's do it on this one, and we're going to start numbering over here. Say that's number 1, that's number 2, that's number 3, that's number 4. And if we start on this one, that's number 1, that's number 2, that's number 3, that's number 4. What we recognize is we've got a methyl group at number 3, a methyl group at number 4. So it looks to me that these two are identical. Let's just check it on this one, and we'd say that this is number 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This alcohol group is at number 3. It's not the same as those two. Let's start the numbering on the functional group. This one is number 1, number 2, number 3, number 4. And that methyl group is a side branch on carbon number 2. So what you should recognize is that there's only 2 that are the same. It's numbers 1 and 3, and the multiple choice option for 1 and 3 is C. Now, I hope you can see exactly how we've eliminated that. And make sure that you can practice. We're going to have some more practice in using the IUPAC system in a few minutes. But I think, Kat, it's time for a break.
So guys, remember that there is so much more to the show. So you need to stay tuned because it is going to be awesome. See you after the break. Welcome back, Mindsetters. I want to wish Ashworth a very, very, very extra special birthday. I hope you are great today because you are here with us. So we'll make sure that we make your day with some physical science. I need to remind you guys of your prizes that you can win today. So there are two CDs. One is Solistic Cuts and the other one is Now 60. And then we have our revision textbook. You guys, this is a physical science one. So you guys, I know that you guys want this. You better enter. And we have the awesome Mindset t-shirts. Guys, please send in your questions, but send them clear and concise. So when we pick those winners, they are the right winners.
Yep.
Hey, John?
We must remember, guys, you must include the code. There's a lot of guys that have entered on the various platform and they haven't put the code. And it's such a pity because yesterday during the draw, you know what? We drew somebody, didn't have the code. Sorry.
So you can't
somebody else had to get the prize. Okay.
So remember that code, guys. It's very important. And if you are SMSing, remember your name, guys. We need your name because we really don't have your number. So you need to put down your name.
On PepText as well, please.
PepText, eh? And PepText.
Because it's really difficult to get back to people on PepText. So if they can put their names on PepText, that would be great. And we'd love to have that. Just to remind you, the code 1669. So get your entries in. We're wanting to see if we can push the limits. We've been getting up to 1,000 entries. So that's why there's such fierce competition for these prizes. But guys, make sure you do the science as well. This is a great question. It's a good standard question, and you need to know what's going on when we come to organic chemistry reactions. So make sure you've got it sorted out. Okay, Kat, just how are we doing on the Facebook page?
The Facebook page is looking awesome. We've got some likes as well, guys.
Look at that, 12,982. We're almost at 13,000.
So I guess people are calling your friends. I know, calling your friends. Hello, like the page right now. Call them up.
Okay, and so let's not delay. Let's get into the science. I know some of you have asked some questions. I'm going to get to those questions as we go through the paper. I know that there are lots, and we'll leave the last 15 minutes or so to take extra questions. But please don't forget, I don't mind stopping going over these questions. If you've got an urgent burning question, give us a call. Post it on Facebook. That number to dial if you want to speak to me, 086 1058-262. Lindsay's waiting by to take your details, and then you'll be able we'll be able to get you on air as well, and we'll get the question down and make sure that we can engage with it. If you've got any questions, phone that number and we'll get on to it. Okay, let's get on to the longer question now on organic chemistry from the November 2011 paper, question number 3. And the first question, which is usually about identifying and naming compounds. It gives you a table here, represents 6 organic compounds. So number A, B, we've got a cyclo, hexane, not hexane, propane there. An alkane cyclo molecule, and we've got something there at D, and we've got E and F. So now, what does it say? We must write down the letter that represents a ketone. Now remember, a ketone, I said to you, is one that's got the carbonyl group in the middle. So it's always in the middle of the molecule. It's not going to be on the end. There could be anything on the end here. We could say R, just to indicate there are other things. But the carbonyl group is in the middle. That's what you've got to look for. So let's go to the page and select the one where the carbonyl group is in the middle. Now, it's not that one. This is an aldehyde. It's not that one because there's no carbonyl group. It's not that one. It's got to be D. Okay? Carbonyl group in the middle. But make sure that there's nothing else. That's what it is. It is right. That's the only answer. So number D. Straightforward. We're doing well with organic chemistry. And guys, for me, it's my favorite section, but I think it needs to become your favorite section as well. Because if you look at the exam paper, the number of marks allocated in chemistry for organic chemistry is a big percentage compared to the other topics. So please know your organic chemistry really well. Okay, so now, next thing. It says that we have a compound which is an isomer of prop-1-ene. Now, here we go. When you're given a question like this, first thing we need to get the terminology. A structural isomer, or isomer, is a substance, compound, that has the same molecular formula, but it has a different structural formula. So let's work out what the molecular formula is for the one that they've given us. Prop. Now, prop, using the IUPAC method, is the prefix. Prop indicates number 3. So I'm going to say we've got 3 carbons. The ene tells us that there's a double bond. So we recognize that there's 1 double bond and it's in carbon number 1. The structural formula is going to look, the backbone is going to look like that. And it's ene double bond. So we don't want to put too many on here. Remember, carbon can only have 4. So I've put too many bonds there. And we've got it right. Fill in the carbons. Check. This carbon is 4. This one, I'm actually going to write it down below. Doesn't matter whether it's above or below. 1, 2, 3, 4. 1, 2, 3, 4. And each of those has a hydrogen. So there we go. There's the structural formula. Now, you can do it in 2 ways. You can draw the structural formula like I have, or you can say, well, it's an ene. So it must obey the general formula, which was CnH2n. We'll check it and use the structural formula to check our answer. So number of hydrogens, 1, 2, 3, 4, 5, 6. And what do you notice? It's 3 carbons and 6 hydrogens. So I hope you've got that. 3 carbons and 6 hydrogens. It follows the structural formula. And we're right on target to make sure that we've got the correct molecular formula. But we haven't finished the question. What we were asked to do is to find the isomer that's like this. So the first step was to find the molecular formula. And the next thing is then to go back and look, because it says a compound which is an isomer. We've got to write down the letter of a compound that is an isomer that has C3H6. C3H6, well, let's have a look. This one has more than 3, so number A can't be it because it has more than 3. Number B has more than 3. Number C has 3, but it's got an oxygen, so it can't be that. This one is more, so it can only be this one, number C. And here we've got a cycloalkane. So what we recognize is we want the letter. The letter for the answer would be number C. Number C. And in this case, it would be cyclo. They didn't ask for the name, but I'm just naming it. Cyclopropane. Now, Kat, I think there was a question on Facebook,
Yes,
which you
there
showed me
was.
earlier, about naming molecules that have got rings in them. Why don't you just read the question,
me
tell us
read
who
it
it
out
was
to you.
from?
Okay, let me just get it.
Okay,
Sorry.
while Kat's getting it, remember that cyclic molecules are really easy. They're straightforward. There shouldn't be a problem with them. You can get cycloalkanes, cycloalkenes, and cycloalkynes. They can also have branches on them. The important thing, and I think this is what the question is about, how do you name them so that you number it correctly? Am I right?
Sorry, John, my computer's a bit slow, but
Okay.
it is about numbering them correctly. Yes?
Okay, let me remember, and I'm just going to take it. I'm sorry we couldn't get the person that's written the question in, but the question was about numbering and naming a cycloalkene. And how do you do that? So if I have a cycloalkene, let me just take an example of a cycloalkene and do something like that. And I'm now going to check. Remember, every carbon has to have 4. So there would be 2 hydrogens on that one, 2 hydrogens on that one, and 2 hydrogens over here, 2 hydrogens over there. So if we look at this structure, what you're going to have a look at is, first of all, let's count the number of carbons. And you're going to start at the functional group. So it's a cyclic molecule, but we're going to pick the functional group, which is the double bond. So I'm going to start, and I'm using a different color, call that number 1, carbon number 1, call that carbon number 2, carbon number 3, carbon number 4, carbon number 5. Now, carbon number 5 says 5 carbons. What's the prefix for 5? Do you have any idea in Greek when we have 5 things, Kat? Think of a shape.
The shape, is it not hexagon?
Hex is 6.
Hex is 6.
Pentagon.
Pentagon,
Pentagon.
that's it.
There we go. So we've got pent. And what we're saying here is that it's a cyclo. So it's cyclopent. And what we've got is a double bond, and we're going to say cyclopentene because of the double bond. Now, guys, if we look at that, you might say to me, but then why did we bother to number it? It's just good practice, because maybe one of these things down here, and they can ask you this. Let me just change the question and say to you, maybe one of those was a methyl group. So maybe we just change the question and we have a methyl group there. And now you're going to have to say it's 4-methyl cyclopentene. Okay? So you can get side branches on them. I hope that clears up the question.
Yes,
Have you
it
found
does.
who?
Yes, I did find it. It was, I don't know how to pronounce the name, but Bilkis.
Bilkine. Hope that helps you.
Yeah.
And we will get on to that and make sure that if you've got any other questions, post them on the page. Hope it answers it. Okay, let's move on. And we're going to the next question, or the next part of this question from the exam paper. And it says to us the following. It says, write down, come back, IUPAC name of the following compounds. Now, I know this is where a lot of learners struggle, and it was compound A. Okay, so guys, let's remember, IUPAC, we need to know prefixes, we need to know suffixes. Prefix, pre, in front of the name, suffix at the end of the name. Prefix for 1 carbon, meth, 2, eth, 3, prop, 4, bute, and so on. You know the detail. For the suffixes, it tells you the functional group. When we're dealing with the hydrocarbons, anes, all single bonds. Enes, 1 double bond. Ines, 1 triple bond. And we need to make sure that we've got that. If it's an alcohol, it will be ol at the end, and it has to have an OH functional group. Ketone, carbonyl, aldehyde, carbonyl, carboxylic acid special functional group with a carbonyl and an OH on it, and the ester special CO and a double and a C and another double O. But we'll get to those. In this case, let's see what we've got. Okay, so we have to name the use the IUPAC formula. And the first thing you identify is what sort of functional group have we got. And I hope you're shouting out to me, well, we've got a carbonyl group. And it's on the end of the molecule. Now, the IUPAC rule is you always identify the functional group and try and number the molecule so that it is at its lowest possible number. So the lowest possible number this can be is number 1. So we're going to number this as number 1. And I'll use a different color to do my numbering. I'm going to call that number 1. Now we've got to number it so that we number the longest chain. 1, 2, 3, 4. Now, guys, I could go down here and number that 5, or I could go straight. It doesn't matter. I'm going to go there, and I've got the backbone numbered. If there was another one at the bottom over here, then I'd have to turn the corner. But in this case, I'm getting the longest chain. So I already know now that I've got 5 carbons in the longest chain. The prefix for 5, we've already discovered, is pent. Let's just rewrite that. So we know the prefix is pent. Now what else do we know? We know that the functional group is for an aldehyde. And they're all single bonds, so they're like the alkanes, AN. For an aldehyde, the ending is L. So it's pentanal. But it's not just straight pentanal, because we've got a side branch. I hope you can see that. There is a side branch, and it's a CH3 side branch. Now remember, CH3 is a methyl group. So methyl, but we've got to say, where is the methyl group? Are you seeing where it is? Number 4, at carbon number 4. So the full name, we put the pieces together. 4 dash methyl. Let's just do that again. And it's very important that we get it right. We're going to say 4 dash methyl pent and L. Please remember, dashes between numbers and letters, commas between numbers. So if we had another side branch and we had like 1 chloro, bromo, or whatever, we're going to put a dichloro, we would put a comma between the numbers. Dashes between letters, and between these, it's one word. We must make sure methyl groups join on to the main branch as one word. So there we go, compound A is named. Now, what about compound B? Let's see if we can get this done, very sorted out, very straightforward. 3 carbons and a double bond. But we need a triple bond at least. There's the triple bond. And we've got carbon number 1, carbon number 2, carbon number 3. And what we recognize, 3 is going to be prop. Now, I like to, according to the IUPAC, put the number of the double or triple bond in the name. So I'm going to say prop 1 ion. That's the best way of naming it. That's the way that IUPAC likes us to name it. You won't get it marked incorrectly if you say 1 propyne, but it's better to do prop 1 ion because it leaves space in case in bigger molecules you've got functional groups or side branches that stick on. Kat, I think we're about finished with the IUPAC naming. Okay. But let's go to a break, I think.
Let's go for a break so everyone can just get refreshed and everyone can get a glass of water, perhaps a glass of water for the next segment. Goodbye, guys. Welcome back, Mindsetters. I hope you guys are refreshed and rejuvenated. I'm so happy to see the interaction on the page. It's fantastic. The questions you guys are asking are awesome, and I'll make sure that John sees 1 or 2 or maybe 3 of them at the end of the show so that you guys have got your science on lock. Over to you, John.
Katlego, thank you so much. Guys, we're almost at 13,000. Have a look at this. 12,992. Get going. Get your friends to get liking the page. We're going to get there. Katlego, you better be watching.
I'm watching.
Make sure that we've got it sorted. And there's a special surprise, I'm sure, for when we get to 13,000. Well, not quite as big as 10,000, but we really want to aim high. Maybe soon we'll be aiming at 15 and 20, and we'll do something special then as well.
It's going to be awesome.
Okay, now there was Marvin had a question, I believe, on the page about
Marvin's page.
A comment, and it's very similar to what I've just said before we went to the break. He said his teacher wants him to write the name of the ketone as butone, and he sometimes writes 2-butanone. Okay, Marvin, and all of you guys out there, in the final exam, both of these questions, both these answers would get marked correctly. Okay, but please notice that this one is the preferred one. Okay, so it depends. Those are given as options, and in terms of IUPAC, this one is accepted unless there is a branch on the side. And that's what is confusing. So rather learn it like this. Rather, as I wrote down over here, put the numbering of the functional group in the name before the suffix. Because then if you want to add anything on this side, then you don't get confused between which is the number for the functional group and which is the number for the branch. I hope that makes it clear.
Yes, it
okay,
does.
Let's move on. Okay, guys, we're into question number 3, which is a great question about a reaction, and it's one that you should really know. We've given this substance, and we say write down the name or the formula of each. See how kind the examiner is to you. He's giving you a prompt when he says, first of all, you can do name or formula, and then he says each. So you must know that there's more than one. Of the 2 products, he actually says 2, formed during the complete combustion of compound E. Now, compound E is an alkane, and we can recognize 1, 2, 3, 4. It is butane. But for 4, ane, because they're all single bonds. And we need to recognize this is what's happening when we burn light gas, LPG gas. You have a Kodak bry or something like that for a heater or something. Even in the laboratory, your Bunsen burners will run on butane or a mixture of butane and propane. And what do they produce when there's complete combustion? Well, CO2 plus water. Okay? And you have the choice of writing it as a formula or as a name. And just to save time, I'm just going to write the formula, and I hope that's okay. Carbon dioxide and water being the answers. But if you write the one as a formula, please write the other as a formula. If you write the one as a name, write the other as a name. Don't mix them up. And don't try and be clever and do both. It's one or the other, and I'm sure that the examiners will be kind to you, but it's best just to keep on their good side and don't annoy them. Right, next one. We're going to the next page, and we've got this question, which is an almost standard question. I would like to suggest to you that if we're dealing with organic chemistry, the chances of you getting asked a question about esters is extremely high. So make sure you know esters, and you know how to name esters, you know the functional groups, and you know all the reactions related to esters. So if we take a look at this reaction here, we recognize ethyl butanoate. You recognize it is an ester. Okay? The functional group for an ester will always have something like that in the middle. And I like to remember esters in this respect because they are fragrant organic molecules. They consist You find them in perfumes and deodorants and all that sort of thing. They have a lovely fragrance. Food colorings, food fragrances as well have esters in them. And the way that I like to remember it is there's a special type of perfume. I'm not very good in perfume, but there's a Coco something.
Coco Chanel.
And it's supposed to be good stuff, eh?
It's amazing stuff.
Okay, and look here. If you remember that special fragrance, what have you got? Coco. Okay, so the functional group for ester, Coco. And so you just remember that, and that way you'll always be able to recognize what the ester is. Okay, so what it says, the name of the homologous series, I've answered that already, ester. And the next one is the structural formula of the functional group of carboxylic acids. Now, I've just given you the functional group of the ester, but what about the carboxylic acid? The functional group is the reactive part of the molecule. It's the unique identifier of the molecule of this family of substances. Now, carboxylic acids, like vinegar, have one carbonyl group and a hydroxide group. So draw it out like that and make sure you've got your bonds so you can show that it's the carbon bonded to oxygen and then the oxygen bonded to the hydrogen. This is the hydroxide group. The hydroxide group is over here and the carbonyl group is over there. Together, that forms your functional group for your carboxylic acids. Okay, what about the next question? It says, give the IUPAC name of the carboxylic acid from which compound F, the ester, is formed. Now, guys, when you look at the name, it's really easy. This part, the initial part, comes from the alcohol, and this part comes from the carboxylic acid. So we can look at the name and recognize that it ends over there. The 8 is the part for the ester, but it's butanoic acid. That's what we want. Now we wanted to write down the name, so butanoic acid. We didn't have to give the formula at this stage, but what we now need to do is to give the structural formula of compound F. Now, what did we notice about it? It was ethyl butanoate. Ethyl, very straightforward. Ethyl, go back to the IUPAC rules. Ethyl, F, 2 carbons. Okay, so what we're going to do is to recognize that's the alcohol side. So we've got 2 carbons. Then we've got the O, then the C, the double bonded O, and there's your cocoa. There's your cocoa. So we recognize that's the functional group. Okay. This is the alcohol side on the left. This came from ethanoic acid. It wasn't asked, but we should just remember, because this time they didn't ask it, next time they might. We fill in all the hydrogens. Don't ever leave a carbon without 4 bonds. Check them. Make sure you don't make a silly mistake. So there's the ethyl part. Now we've got butanoic, and we need bute. Remember what bute is. Bute is 4, and we've only got 1 at the moment, so let's put in the other 4. And guys, here I'm going to just make some space. I can turn the molecule. It doesn't matter. Organic molecules can be straight or they can be bent. I'm just running out of space here, and I'm putting in all the hydrogen linkages as well. The molecule isn't really going to do this bend, but it's the way we're representing it. So let's just check it and make sure that we've got it right. I'm changing the color of my pen just to make sure. 1, 2, 3, 4. And that would be the butanoic acid part. 2 for the alcohol part for the ethyl. So there we've got it. We've got the structural formula of compound F, which was ethyl butanoate. Okay, right. Let's see if there's one more question here. We're going on to another question. At this stage, are there any questions
Yes,
on
there are.
IUPAC or naming? Let's see what we've got.
Okay, let's see. Let me read you one of these.
Anyone? Doesn't matter.
Okay. So someone asked the difference between the melting point and boiling point. Maybe you could go over that quickly for them.
Okay, excellent question, because what we're going to directly after this is we're going to go to a question that examines the trends in melting point and boiling point. So let's just do a quick revision. And what we recognize is melting point. It's a special temperature, so it's the temperature where there is a change from solid to liquid. Okay? Now, guys, for a pure substance, every pure substance has a unique melting point because the bonds and the intermolecular forces are the same. And it requires a specific amount of energy to change them from being grouped together as a solid to being a liquid. And in fact, what you'll recognize, if you speak to some of the grade 10s, they will have done a prac earlier in the year where they looked at the heating curve of water and the cooling curve of water. And when water heats up, as an example, we know its melting point is 0. You can take a collection of water or an organic substance, doesn't matter, but the principle is the same, as long as it's pure. And if you heat it, as long as you've got ice present in this collection of water, the temperature will be 0. If you continually stir it, as soon as all the ice has melted, it will then start to increase. So it's a critical point where all the water has changed from liquid to solid is also the melting point, even though it's kind of like the freezing point as well. So melting point is the transition point, the temperature at which something changes from solid to liquid or liquid back to solid. Okay, so that's an important point. Now, notice that this is it's unique for pure substances. So in organic chemistry, we can even test and identify that we've got a substance that we're trying to synthesize by looking at the melting point. And so there are tests that we do. But now, when we deal with boiling point, and here's the confusion. Here is also a little bit of confusion that I want to clarify. When we look at boiling point, well, let's first of all do something like this. If we could have liquid going to gas. Now, guys, the problem here is that this process of liquid changing to gas can in fact happen at any temperature. We know this.
Yes.
Because if you spill some water or if you perspire, it will evaporate. And evaporation takes place at any temperature. So this process of liquid changing to gas can take place, and it can be at any temperature. It can be called evaporation. That's the first process that you need to understand. But there is a point, and this is the important thing. There is a point where the liquid can no longer exist, where at a particular position you can't get a liquid anymore. And there are some details here that I want to just go over. And I want to look at the process of boiling, because boiling is different from evaporation. Boiling happens at a fixed temperature, but we must add at a fixed pressure. Okay, so this is really important. If you're living down in KwaZulu-Natal, or if you're in Gauteng and you go to KwaZulu-Natal on holiday or to Cape Town on holiday, you will notice, and I'm not sure if you've experienced this, if you go and get your cup of tea in the morning and you're down at the coast and you think that you can just quickly drink it, what happens?
You can't.
What do you notice? It appears
hot.
Much hotter than up here.
Hot, yeah.
Okay, and the reason for that is that there is a difference in pressure. So at sea level, the amount of atmosphere pushing down on the liquid surface is greater than here at altitude in Gauteng. So what has this got to do with boiling? Let me try and explain, and I'm going to draw a picture. Let's imagine that these are little molecules in my beaker, okay? And what we've got above the liquid is we've got little air molecules. And I'll put them down. Now the air molecules are pushing down. This is atmospheric pressure, okay? Now boiling happens when the molecules that were the pink ones start to fill the space above the liquid. So here's liquid, and here is gas. Now, if they get into this space above the liquid, they start to exert a pressure. And we call this vapor pressure. Now, what we recognize is that when the vapor pressure cancels out the pressure of the air pushing down, then there's not so much stopping these ones from getting up into that position. You just go back. So these ones are able to escape much easier. When we get vapor pressure, which we call VP, when VP equals atmospheric pressure, then we get boiling.
Okay, I'm
So,
sure that's...
guys, this is really important. And it's very important for you to think about as well. If the pressure is higher, then you're going to get more vapor pressure. So that's why you get more energy. That's why at the coast, the temperature is higher for boiling.
Yes.
But it's a unique point. It's a special temperature that the liquid can no longer exist. No longer exist at a temperature higher than that. So if I tell you that the boiling point of a substance is 76 degrees, then that substance cannot exist as a liquid at 77 degrees.
Okay.
Okay. I hope that clarifies
Yeah.
the difference between boiling and evaporation, as well as melting point and boiling
Yes,
point.
it does. Pumelele, great question. That was an awesome question, and I'm sure that answers it for you. Guys, send in all your questions that you may have on organic chemistry, and we'll answer them. See you after the break. Welcome back, Mindsetters. I've got sad but happy news. The competition is now closed. You can no longer enter. We will be considering the answers that we have already on the various platforms. So it doesn't matter if you perhaps called, if you SMS'd, if you emailed, if you pep texted, if you Facebooked. You should have answered already, but you know that any of these work because we consider all of them, all. If you have the code, if you have the answer, if you have your name, you will be considered. So don't worry. Hey, John.
Thanks, Kat. Great, guys. I'm glad to see that so many of you entered the competition. Remember that it's about making sure that you can get those great prizes, but also just to do some revision of organic chemistry. That's the purpose of the competition. And remember, you've got chances to enter next week as well. All the way through next week, the grade 11s will be on this weekend. If you've missed the live show, you want to see a repeat of the live show, be on this weekend from Saturday and Sunday, starting with maths in the morning, then science, then life science, then maths literacy, accounting, geography into the evening, as we normally do on the weekend. So catch the repeat versions Saturday and Sunday. We'd love to have you join us. Of course, we won't be running the competitions again on the weekend, but we'd love to have you commenting and making sure that you're up to date. But next week, Monday, grade 11, following weekend, grade 10, the competitions are open to everyone. Okay.
Also, John, some great news before you carry on. We have reached 13,000
great.
We are actually now 13,003. So that is
Excellent,
awesome.
guys. Well done. We're going to have a look and see who was the 13,000th. And there will be a surprise at the end of the
There will
session
be
for that person. We'll make sure we get that sorted out. Okay, guys, we were talking about boiling point, and the next question in the November 2011 paper was about boiling points. And this is really important because it deals with an investigative question. It deals with the process of chemistry and the scientific method. And there are lots of times that this gets asked in the chemistry paper, either as a rates question or as an organic chemistry question. So I just wanted to go through it with you very quickly. It tells us that we've got 3 hydrocarbons, A, B, and C, and we're told that these hydrocarbons have a molecular formula, C5H12. Recognize that's an alkane straight away. Okay, they're used to investigate branching, the effect of branching on boiling points. So they've given you a lot of detail already. They give you the results in a table, and they say to you, write down the term used to describe compounds with the same molecular formula but with different structural formula. We can say these are structural isomers. And we covered that earlier in a different question. So I'm not going to spend too long on that. We've mentioned isomers already. The dependent variable. Now, what is the dependent variable? The dependent variable is the one that you don't control. So in other words, it's the output, it's the outcome. Which one are we controlling? Which one are we choosing? Well, we are choosing, in this case, the molecule, the structure of the molecule, the number of branches. So in this case, the dependent variable is the boiling point. We can't predict that before we start. But what we can do in the independent variable is the number of branches. And what things are we keeping the same? When we do any investigation, in this case, we are keeping the formula C5H12 or the mass, molecular mass, the same. We're using the same molecular formula. There are a whole lot of other things that you would make sure of. Obviously, you could also say that we need to keep the pressure the same. Needs to be done in the same place because we recognize boiling point will change with altitude and with pressure as we described earlier. Okay, let's move on, and we've now got to try and look at these results and say, are these saturated or unsaturated? Well, we said they were alkanes. Now remember, an alkane is saturated. What does saturated mean? It means that every carbon has single bond to it. There are 4 single bonds to every carbon. There are no double or triple bonds. So yes, it's saturated. Remember very quickly, I know it was in the earlier session, the test for saturation and unsaturation. If you bubble a gas that you suspect is unsaturated through bromine, the color of the bromine will disappear. If you bubble a saturated hydrocarbon through bromine, the color will remain. That's because there's an addition reaction taking place there. Let's move on. We get to the next thing, and it says, which one of the following has a straight chain with no branches? Write down the following. The letter A, B, C that represents this carbon. Now, guys, if we've got a long carbon chain, then we need to recognize it has a big surface area. If it's got a big surface area, there's lots of places that intermolecular forces can interact with it. It means that you're going to need more energy. So the long carbon chain is going to need more energy. So it will have a higher boiling point. So if we look at it, the one that's got the highest boiling point is A. And we're going to say A is the one that is the longest chain. And we have to give its name. The IUPAC for C5H12. And we can automatically say that is pent. And because we know it's an alkane, it's pentane. Okay, I think that we're almost at the end of this question, and we'll get to the next interesting part of it. It was over here. It says, consider hydrocarbon C. Now that has a boiling point of 10 degrees. So notice it's very low. Write down the structural formula of this hydrocarbon. So now we've got C5, and we recognize it's going to have the most branching. So I'm reckoning that it's going to have 3 in the branch and something like that. I'm going to do a semi-structural formula here just to save time. So put the carbons in. Notice we've got 3 carbons in a straight row. 1, 2, 1, 2, 3. These are branches. There's the branch. So the name of this, just so that you can get it right, is going to be propane. And what is the side branch? 2,2-dimethyl. And this should all be one word. I haven't made it one word, but it should be. I just ran out of space. Now, I know there was a question earlier, I saw it on the page, about what happens if you don't put the dashes and the commas. Guys, you can get marks deducted. So please make sure. IUPAC is very specific about the commas between the letters and dashes between letters and numbers. And even as I've written it there, it should be in one line. We need to make sure that we do use our space. Please just ignore that for the moment. I just ran out of space. It wasn't part of the question, but we've got it sorted. Right, now, explain why hydrocarbon C has the lowest boiling point. In your explanation, refer to its structure, intermolecular forces, and energy. Now, guys, they've actually given you the tips on how to answer the question. It's for 3 marks. The first thing they said, what's its structure? So what we recognize this structure, because it's got it's got 2 branches, or the most branches, 2 branches, it is more spherical. And if it's more spherical, what's the second point? Intermolecular forces. It's got weaker intermolecular forces because it's got a smaller surface area. And therefore, it will need less energy to break the forces. Okay, and that's why it has a lower boiling point. Okay, and so we've got lowest boiling point. Right, I think I've got one more part to this question. Let's just see where we are, and that's it. Okay, I was right. So one more part, and it's the last part. It says, which one of the following hydrocarbons, and it's an interesting part because we've mentioned it, A, B, or C, has the highest vapor pressure? Now, the question is a little confusing because it should have said the highest vapor pressure at room temperature. And this highest vapor pressure means that it's the one that is going to escape from the liquid to form a gas easiest. Okay? Which one is it going to be? The one with the lowest boiling point. So what we're going to do is we're going to say highest vapor pressure is number C. Why? Because it has the lowest boiling point. Remember, at the boiling point, the vapor pressure would be equal to the atmospheric pressure. So we can't compare the vapor pressure at all their boiling points. But at the room temperature, or even at, let's say 5 degrees, or at 10 degrees, the C would have the highest vapor pressure. We'd need to make sure that we've got that very clear. The one with the lowest boiling point has the highest vapor pressure. Okay, Kat, I think there were a couple of questions,
yes.
So let's get on to those.
Okay, cool. Let's get on to the alcohol ones. So both Sia Demore and Xavier Murray asked, yes. Okay, what is the name of the functional group of alcohol, and what are the differences between primary, secondary, and tertiary alcohols?
Okay, excellent question.
So maybe you can do those together.
I will do. Okay, so guys, I'm just quickly drawing up a simple alcohol, and what we need to recognize is that here we go, this OH group, which is known as a hydroxide functional group, is the part of the alcohol. Okay, so that's the functional group, OH. And I want to stress again, when you write these up, please indicate the bonds between the O and the H, and don't just write COH. You must show the bond between the carbon and the oxygen and the hydrogen. Now, the classification of alcohols, Kat, is I think what he was referring to,
Yes.
refers to different types or different families of alcohols. We have those that are called primary alcohols, secondary alcohols, and tertiary alcohols. So this one is a primary. And I'll explain exactly why. Because on this carbon, let me change the pen color for that because I want to highlight it in a different color. Let's make that. How many carbons are attached to the one that I've circled, Kat?
How many carbons?
How many carbons?
1.
1. And that's why this is primary. There's only 1 carbon. So attached to the one that is attached to the O,
Yes.
there's one
There's one.
carbon. Okay? So that's why it's primary. If we had to change the molecule slightly, and I'm going to use an isomer of, no, I won't use an isomer. It's just going to be too difficult. Just change the position of the, this one will be an isomer in fact. Change the position of the hydroxide. Okay, now let's do the same thing. Circle in pink, the one that's attached to the O. How many how many carbons are attached to the pink one?
2.
Okay, so if it's 2 carbons attached to the pink, it is secondary. Okay,
Okay.
let me write it in words. It's a secondary alcohol. Okay, guys, hope you got that. Can you guess what the tertiary alcohol will be?
When 3 are attached.
When we've got 3. So let's have a look at a structure. And now this one won't be an isomer. What we'll do is we'll just simply take something like this. And I'll put semi-structural formula in rather than structural. And if it was semi-structural, I can actually put OH, but I'm not going to. There's that. Can you see how many carbons are attached?
3.
1, 2, 3. So this is a
Tertiary.
tertiary alcohol. Hope I've spelt it right.
Yes, you have.
Okay, cool. Next question.
Awesome. The next question is the difference between a base which is diluted and concentrated.
Okay, guys, this is often asked in terms of reactions, but just remember, concentrated base, concentration is C equals N over V. So it just means that there's a high number of moles of the substance in a small volume of container. So you could have a concentrated solution of sodium hydroxide. It would have a concentration of something like 5 moles per decimeter cubed. But a dilute substance would be something like 0.5 moles per decimeter cubed. Now, when you're doing hydrolysis, then you usually use dilute solutions of sodium hydroxide, of an alkali, and that's where it's important to know the difference between remember both of these, sodium hydroxide is a strong alkali, but it's concentrated or diluted. It's the same stuff. It's just the amount of water that you've diluted. It's like taking a drink like Oros and putting a little bit of water, putting lots of water.
Yes.
Okay?
Okay. Thank you, John.
Time for a break.
I think we'll go for a break. Thank you. That was Ashworth, the birthday boy's question. So
Okay,
well done.
great. Well done, Ashworth. Go for it.
Okay, let's go for a break, guys. Remember that this is going to be our last segment, so get in all your questions really quickly so that we can try answer them for you at the end of the show. See you after the break. Welcome back, Mindsetters. I am loving today because you guys have just been so awesome on this Friday, the questions and the answers and the helping each other and the motivation and how your prelims are going to be, they are going to be absolutely awesome, and you guys know it. Number 13,000. This has been so great, guys. We've reached more than 13,000. I think we're on 13,010 now. So you can thank all your friends and your moms and your cousins and your brothers and your sisters, because they have helped us reach our target and beyond. Thank you, guys.
That's great news, eh?
It's such awesome news.
And guys, we'll make sure that we get the lucky person. That was number 13. We'll be sending them something. We'll make an announcement towards the end. Right, now what about that competition question? Now, this is a section we haven't had time to deal with organic reactions, so I'm going to take you through the competition question, and if we've got time, we might do another one or two organic reaction questions. But let's go to the question, and let's make sure that we've got it right. It's the reaction of iodine. So we're dealing with the reaction of iodine and 2-methyl-butene. So before we go and look at the options, what we recognize is we've got iodine and we've got 2-methyl-butene. If I'm not mistaken, let me just make sure I've got it right. Butene. So but is 4. So we recognize that the double bond has to be on carbon number 2. So we've got a number from the end, 1, 2, 3, 4. We've got but, and the double bond needs to be on carbon number 2. And the other thing that we had on this molecule was that we had a 2-methyl. So we need to put the 2-methyl in as well. So on carbon number 2, we've got a methyl group as well. Now let's fill in the hydrogens. And make sure that there are 4 bonds only. So we can't put anything above here. Nothing must go above there. Take that one out. There's no bond there because it's gone to the double bond. And this one has 3 hydrogens. This one is missing a hydrogen because it's only got 3. 1, 2, 3, and there's the 4th one. This one needs 3 bonds on it. Carbon number 4 needs 3 bonds on it, and there we've got it. Now, guys, as soon as you see the double bond there, and we now recognize we've got iodine. Now, iodine is one of the halogens. Okay? It's like chlorine, bromine, and fluorine. And we know that these are all strong oxidizing agents. So they are oxidizing agents. They love to take electrons. And there's this double bond there that's got this spongy layer of electrons, lots of electrons that are delocalized in that second bond. It's going to try and jump in and grab those electrons. And the type of thing that happens here is that it's going to pull the double bond apart, the second bond, and make 2 bonds out of it. And I just want to illustrate that because I hope you never forget this. If we take that, what we recognize will happen, and I just want to draw it in a different way, just so that we can see if we can get this board making it look good, to illustrate it for you. Think about the double bond as being 2 parts, and what happens is as we get the iodine over here, the iodine over here, okay, it kind of wants to partner, and so it kind of starts to link up, and it forms this thing here. Now, what has to happen is the iodine has to let go of each other, first of all. So when it lets go over there, and we're going to take that one out. It's not doing what I wanted it to do. I'll just do the eraser thing. It takes that one out. And this, which I've drawn as a dotted line, now becomes a more permanent one. And we pull that up, and hopefully we can get it to do that and move over there. And it opens up a bit like a bridge, and it pulls into this position over here. So if we can just get it to get in the right orientation, we'll be right. And so the double bond which was over here, is now broken, and we've got 2 single bonds. That process is called addition. Okay? And I hope you've got that you recognize that the answer for the question, therefore, was number C. It was addition. How do we tell the difference between addition, substitution, and elimination? Well, I'm going to take it backwards first of all and say the way that I remember this is as follows. If I've got addition, then I'm going to start with 2 reactants and I will have 1 product. And you can identify that addition. In this case, another name for this process would be iodination or halogenation, because we are adding a halogen in. But it's really, in terms of the topic, you would say it's addition. 2 reactants, 1 product. Well, what about elimination? Well, elimination is the opposite. You start with 1 thing and you end up with 2. So you start with 1 reactant and you end up with 2 products. And then substitution. Well, substitution, you guys know all about substitution. You've got 5 people on a team or 11 people on a soccer team, and when one person isn't playing so well, or you want to put an impact player on, you take one person off the team and you put another person on. So you always have, for substitution, you'll have 2 reactants and you'll have 2 products. But they'll be different. They'll have changed. Both of them will have changed. So there'll be a double change. Please make sure you understand the differences between those reactions. Katlego, are there any quick questions?
There aren't any more questions, John, so...
Okay, no, but that's fine. I just wanted to check and make sure that we've got that. I want to just make sure that we've got one last little thing, because we've got, from the November paper, a quick illustration of what I've just explained about addition and elimination and substitution. Here is the question. It was from question number 5, and what we're given is a flow diagram. R, P, and Q R, P, and Q represent different reactions. So there's the P reaction, there's the R reaction, there's the Q reaction. Let's have a look and see what we can do. It says name the reactions. So remember what I said over here. We're going to get an alcohol in this one's place. So what's happening? The double bond has broken and we're getting an alcohol. So I reckon that for P, what we're doing is we're adding water. When you add water, it's called hydration. And it's an example of addition. Okay, I've got very short time. I want to get Q. Q over here, look what happens. We're getting an alcohol as well. So we are taking out the bromine and we are going to substitute. And then for R over here, what we're doing is we're eliminating. So make sure you've got that and you can get the answers very clearly. Okay, Katlego, right about time.
Thank you, guys. We've had an awesome show. We've got a winner. Sidonia Dias, you are the winner for this show. So you'll be getting all your stuff. Send in all your detail. And Siadimo's mom, we are going to give you a t-shirt as well for being the 13,000th winner. Thank you for an awesome show, guys. Remember to learn more and learn extra. And we'll see you next week with the grade 11 show. Enjoy your weekend, guys. Bye-bye.